to modules. And then let's head on down to week 7 lab. So right there's week 7 lab overview. All right, and then here are the lab steps. An array is a group of variables. And let's see. This is going to be a Word document with the project code and screenshots. We're going to be doing templated classes. Okay, there we go. That makes sense. All right, we can definitely do that, no problem. All right, let's boot open Visual Studio. All right, I'm going to create a brand new project. And this is going to be C++, and it's going to be an empty project. And then I'm checking the location. The location makes sense. So at this point, let's go ahead and pop this, and we're going to call it week 7 lab. Visual Studio creates a project for us. Then I'm going to come over here and right click on source files. I'm going to hit add, new item. It's going to be a C++ file. And go over to toolbox. There's a starting code. I'm going to drop it in here. And then this is week 7 lab. All right, so it looks like it's ready to go. And I'm going to go over here to instructions. Array is a group of variables. You'll use arrays frequently. The only problem with an array is that you cannot resize the array, and that is a huge problem. Once you create the array, the size cannot be changed. So once you make it 10, then it stays 10. So if you need to resize the array, you have to use dynamic array. And actually, even using dynamic arrays, once it's created, it's locked. That's it. So once you create the array, it cannot be changed. So what can you do? You can use the standard template library and then use a data structure called a vector. And the vector is an array list. So in languages like Java and C#, it's actually called an array list. But it's the same thing, but we call it a vector in C++, all right? So the array list or vector can use any data type, but the question then becomes how? Is it able to use any data type? And the answer is because it's templated, all right? And the templating is what we were talking about on Monday. So we were talking about Monday, we did a function template, we did a class template. If you template it, then all of a sudden you can use any data type, which is fantastic, okay? So we're gonna create a templated array list class, and that is the objective for this lab. So we're gonna create the week 7 project, and templated classes cannot cross files, as we talked about on Monday. So right click on the header files, and then we're going to add a new item, and we're going to call it arraylist.h. All right, so here we go. I'm going to click over here. I'm going to go over here to the header files right here. I'm going to right click on it. I'm going to hit add new item, and then there's header files right there. And then I'm going to call it arraylist. And this is our arraylist.h. All right, hit your add, and Pragma 1 is up here at the top, so that's good. That's put in there for us by default. All right, put the tag templated class T to tell C++ that we're creating a templated class. Then we're going to create the array list class, and then the semicolon goes at the end. So template class T. So right here, we're going to say template, and then we're going to say class T, like that. All right, template class T. That looks good. All right, then we're going to create the array list. So here we're going to say class array list, and then curly brace enter key. And Visual Studio 2015 puts a semicolon automatically at the end for us. So I'm certain that 2017 and 2019 will do that as well for us. All right, awesome. Okay, so let's go ahead and see what's next. So we've got this set. So in number 2, let's add our attributes. Remember, the attributes need to go into a private section, and that's data hiding. And that's a very critical concept in object-oriented programming. So we're going to create a constant called default size and then set it to 5. So pop up here, we're going to do our private section. And then we're going to do our public section, like that. And then in the private section, we're going to do our attributes. And the first thing we want to do is do that constant. So to do a constant in a class, it also has to be static. So we're going to say constant static, and then it's going to be an int, and this is going to be default underscore size, semicolon. All right, let me make sure that this is looking good. Constant static int default size, setting it to 5. So let's go ahead and pop over here. Constant static int default size, and then we're going to go ahead and set it to 5. All right, so add a pointer so that we can put a dynamic array in the class. The data type should be T, because we have no idea what the data type is going to be. So they're going to tell us the data type by using brackets like this. All right, so just that capital letter T is the class type, and it kind of explains it right here for us. All right, so I'm going to go ahead and pop over here, and let's see down here T asterisk list. So I'm going to pop over here, and I'm going to say T pointer list, and then we want to have 2 int variables so we can keep track of how many items we have in the array. And we're going to do count and capacity. So I'm going to pop over here, and then I'm going to say int count, and then int capacity, like that. Now count is different from capacity. So let's make a little note. This is how many items we have. All right, and this right here is how big is the current array. So this list right here is going to be an array. It's going to be a dynamic array. And every time we fill it up, we're going to double the size. So we're making it bigger. Initially, if we use the default, the initial array is going to be 5 large. But then when we fill up those 5, then we're going to increase the size. We're going to double it. Michael?
The only way to increase the size of an array is to make a new array, copy everything over to the bigger one, and delete the old one.
Michael's just explained to us what this class is going to have to do, because he said that the only way to increase the size of an array is to create a brand new one, copy over all the items from the old one to the new one, and then delete the old one. And he is 100% correct. All right? You are 100% correct, Michael.
I remember doing that for JavaScript. That's always a pain.
Yeah, yeah. Because an array, an actual array, a traditional array, once you set the size, it cannot be changed. All right? And that's why the array list exists, because it will take care of all of the underlying work, copying the items over, creating the new array, deleting the old array. All right, so this right here is how big is the current array. And this is how many physical objects are in there. So if you have 3 items in there and the array size is 5, the count is 3 and the capacity is 5. All right, so you have room for 2 more. All right. Okay, so now we're on step number 3 already. Let's create the constructors and destructors. The first constructor should create a dynamic array. So that's the default constructor. Should create a dynamic array that is set to the default size. And then the capacity should be set to the default size as well. All right, so let's go ahead and pop that over. And then it's going to be / constructors and destructor. All right, so we're going to say the class is array list, and that's our default one right there. And let me see if we're going to be doing it below. We're going to be doing the, nope, they're going to have us do the code right here as we go. So we could have done the prototype here and then did the implementation below it, and that's still in the same file. So that would have worked as well. But right here, we're just going to take the easy way out, and we're just going to go ahead and just create it as we do this. Okay, so I'm going to pop over here, and here's our default. So if they don't give us a size, then we're going to go ahead and say list. So the array that we're going to create is going to be a new array of data type T, because the data type T is a template type. We don't know what kind it's going to be. They're going to tell us. So it could be anything. And then the size is going to be the default size, like that. And then the count is going to be 0, and the capacity is going to be the default size. Now the count is 0 because we don't have any items in it at all. The default size is how big we created this array, and that is going to be our capacity. All right, so now I'm going to pop over here, and they put the capacity first and then count second. It doesn't matter. All right, so now we're doing the initial, we're doing this one right here, which is our second one. And then let's see. Since we created dynamic array using the new keyword, the array was created on a memory heap. All right, so before we do that, let's go ahead and finish this one right here. The second constructor should create the capacity to whatever given size they told us, and the count should be set to 0 still. All right, so pop back on over here, and this is going to be our second array list. So I'm going to say array list is going to be our second constructor, I should say. But this one, we're going to allow them to tell us the initial size. So you tell me how big this should be. And if you do, then I'm going to create an array that's that big of data type T. So that's going to be the initial size, like that. And then the count is still going to be 0 because we don't have any items in there at all. And then the capacity is going to be set to whatever they had us create for the capacity. So however big we made that array, that's the capacity that we're setting right here. Does that make sense to everybody? All right, so now we want to create our destructor. And the destructor is just like the constructor, but we have a tilde. And that tilde is at the top left-hand corner of your keyboard. It's to the left of the number 1. And you hold down your shift key to get it. So there's my tilde, and I'm going to go ahead and put the array list. Left paren, right paren, curly brace enter key. The autocorrect corrected out the tilde. No, I need my tilde. Leave it alone. All right, so since we used a new keyword right here, we've got to clean up our memory. Remember, anytime you use the new keyword, you need to use the delete keyword. Remember that? Otherwise, you will get a memory leak. All right, so I'm going to pop over here. And then it says, because we created a dynamic array using the new keyword, it's on the memory heap. And we have to clean that up. So check to see if the array is set to null PTR. If it's not, then you need to go in and clean it up. All right. So then they kind of gave us some code right here to do that. Okay. So here we're going to go ahead and say / delete the array pointer if needed. So we're going to say if the list is not equal to null PTR, then that means that it has not been cleaned up. So we're going to go in there and we're going to clean it up. So we are going to use our delete array. Remember, this is a dynamic array, so we need to use our brackets right there. Delete the array list. Then we're going to set the list pointer to null PTR. So that way we don't, by setting the list pointer to null PTR, we will not try to delete it twice. If you try to delete it twice, the first time we'll delete it, the second time we'll crash your program. Okay? So that's why we have to do that. All right, everybody with me? Catherine, how are you doing?
Hi, Professor. Pretty much caught up.
Awesome. All right, in that case, let's keep going. So now you said pretty much caught up. Did you want to see one of my constructors? Or
no, I'm just finishing up the destructor.
Perfect. Okay. All right. So we use the new keyword up here in our constructor, and that is when the object is created. The destructor automatically runs when the object goes out of scope. So that's the perfect time to clean it up. So that's where we're using our delete array. All right, let's go ahead and pop over here and see what's next. Step number 4, there's some functions that are generally considered a required part of the array list data structure. First, we need a method called isEmpty that returns a Boolean telling us whether or not it's empty. You can determine if it's empty just by looking at the count variable. If the count is 0, then it's empty. That's pretty easy. All right. The second one is we need to get the data at the requested position. So with that right there, they tell us to get 5, then we're going to give them the data at position 5. So that's pretty straightforward. Okay, so this is the code right here that we're going to be popping in there. And I'm going to go ahead and say / behaviors. And then we need to return back a Boolean, and isEmpty is the method. So curly brace enter key. And we're simply going to say if the count is identically equal to 0, then we're going to return true. Otherwise, we're going to return false. So if the count is 0, that means that we have nothing in there. So that means it's empty. So that's pretty straightforward. And it helps if you correctly spell else. All right, and then the second one is the get method. So with this one right here, we need to return the data. The data type, if we say, so this right here is going to be the data type, and the get is going to return that data type. Now, here's my question. String, integer, double, those are all data types. Char, that's a data type. What's the data type for our array list? T. Patrick said T. Okay, he's 100% correct. We have no clue what the data type is. So we have to use the template T, because they're going to tell us the data type. And that's what this top part right here is all about. Right here, template class T. So the class is T right there. That's our data type. And when they use the arrows, the brackets right here, they're going to tell us string. They're going to tell us employee. They're going to tell us double. They're going to tell us whatever they want, and that's going to be our data type. That's what this is all about up here at the top. Okay, so Patrick's right on the money. The return type is going to be T. All right, so now here we're going to do int, and then we're going to say index. So you tell me which one, which position to give you back, and I'll be happy to do that, no problem. All right, and then we're simply going to say if the index position that you tell me is less than the count, then that means it's a valid index. So I'm going to return the list at position index. Otherwise, else, I'm going to return null, which means I'm not going to return anything at all. And null is actually all caps in C++. So null, like that. All right. So I'm going to pop over here and see index as a position. Do you all like the word position for the array position, or do you like the word index? Which one do you understand better? Which do you like better? You want me to use position like they did, or do you want me to use index? Everybody's all same. All right. All right. I got one vote going for position, so let's go ahead and pop position. Now this if block is really critical, because if somebody says, give me back position 7, but we only have 6 items, the application will crash if we did not do this validation. All right, so that's why that's really important that we do that. And notice how I'm returning it. I'm saying our array, that index position that you tell me, I'm going to give you the item in our array at that index position. All right, so, oh wow, check this out, everybody. Here, they actually cut it down to one single line. Because here, they're just saying count is identically equal to 0. And that's a statement. If count is identically equal to 0, then that's going to return true. Otherwise, it's going to return false. I like that. I like that a lot, actually. All right, let's go ahead and pop over here. And if you want to keep the code like this, go for it. Okay? However, it can actually be done with one single line of code. You can actually return count is identically equal to 0, just like that. And that's done. Because count is identically equal to 0, that's a yes-no question, isn't it? Or a yes-no statement. It's going to give us back true if it is 0. It's going to give us back false if it's not 0. And guess what? That's what we're trying to return. Either true or false. Boy, I like that a lot. All right. So let's go ahead and pop down to the step number 5. This section is the most important section of the array list class. We need to create an add method that allows the user to add data to the array list. And then here's the big question is what happens if we add data that's equal to the capacity? So in other words, we try to enter position 5, the capacity is 5. If the capacity is 5, that means we have 0, 1, 2, 3, 4. But we're trying to add index 5. We don't have that slot. We don't have that availability. So at that point, we have to check and see if the count is equal to the capacity. If the count equals the capacity, that means we don't have any spaces for the new data. So we have to then create an array, and this is what Michael was saying, we have to create an array that's bigger, and in this case, we're going to create an array that's twice as big as the current array, and we're going to call that array temp. Then we have to copy all the items from the current array to the new temporary array. Then you have to delete the current array, and then you have to copy the temp pointer to the current array pointer. All right, so in all cases, copy the data to the count position of our array, and then now that we've added the item, we want to increment the count. All right, so that is a chunk. All right, so let's go ahead and pull that off. and add an item to the array list. We're going to come over and say / add an item to the array list. So it's going to be void. And let me make sure that return type is void. It is right there. All right. Then add, and then the data type is T, and then item, and then we're going to add it here. And they're using data. I like data because we're going to be adding data to this. So instead of saying item, I'm going to go ahead and just say some data. All right. So the first thing we want to know is, do we have enough room? So if the array is full, then that's when we need to double the size. But if the array is not full, then we just add it. No big deal at all. All right. So let's go ahead and pop on over here, and we're going to say if. So we're going to check to see if the array is full. So if count is identically equal to capacity, then that means that it is full and we don't have any extra spots. All right. So if we don't have any extra spots, we have nowhere to put the new data. So at this point, we are going to create a new array. Then we're going to copy all of the items from the current array to the new array. Then we're going to delete the old array. So that's the 3 steps right there. All right, and that's what we're after. So to create the new array, we're going to go ahead and say the new capacity is going to be set to the old capacity times 2. Remember, the right-hand side is done first before the left-hand side is done, okay? So we're going to take the old capacity, multiply it by 2, and then we're going to assign it into capacity. So from this line forward, our capacity is going to be twice as big, all right? Then we're going to go ahead and say temp, and temp is going to be a pointer. So we're going to say data type T temp is going to be a new array of data type T that's going to have the new capacity, like that. So this new temp array that we're creating is going to be literally twice as big. All right, so now I'm going to flip over here and just take a look at that, and that looks good. They put the 2 first, but it doesn't matter if the 2 is first or last, it doesn't matter. All right, so now we need to copy all of the items from the old array to the new array. So let's see here, while I is count. All right, so we're going to create a for loop. So go ahead and type in 4. And then remember, if you type in 4 and then hit your tab key, then Visual Studio will automatically write the entire for loop for you. And then I'm gonna do every single current item that we have. So we're gonna say count like this. And then we're gonna say our new array at position I is going to be assigned our old array at position I, like that. So that right there is how you copy every single item from the old array to the new array, just like that. All right, let me go take a quick look. That looks good. And then we need to delete the old array. So we have to clean up our memory. So we're going to go ahead and say delete array list. So the old array is gone. And then we need to give the old name to the new, bigger array. So we're going to go ahead and say list is assigned temp, like that. So from this point forward, when we say list, we are talking about our new temporary array. It's no longer temporary, it's now our focused array. All right, and that's what this line right here is doing. All right, now remember, this is an if block, so this entire block of code will only happen when we are full, when we have maxed out our array. That's the only time this block of code is going to run. Okay? All right. If we have room, or after we create more room, we need to add the new item to our list. So we're going to go ahead and say list at position count is going to be assigned the data that we have brought in. And then we need to increment our count. So we're going to simply say count plus plus. So once we have increased the size of our array, we're adding a new item. We're going to put that item at list at 5. Okay? And that's where the data is going to go, into our array at position 5. Then we're going to increment count because we actually now have 6 items. 0, because we're 0 based, right? 0, 1, 2, 3, 4, 5. We have 6 items. And this right here is the meat and potatoes of an array list. This is the biggie. All right, Catherine, here's the top of the add method, and here's the bottom of the if. So check your if block and make sure that your if block has all the lines. There's 3 sections, 1, 2, 3, well, technically 4. So make sure you've got all those lines for your if block, and then let me know when you've got that if block completed. It sounded like you tried to say something, but your voice broke up. I could not understand you.
Oh, okay. Can you hear me?
Yes, I can hear you now.
Yep, I'm good.
Okay. All right, now let's look at the bottom. Do you have these lines here? And that's going to be right underneath the if block. All right, let's go ahead and hit build, rebuild. So build, rebuild. And make sure we don't have any problems at this point. So you can see right down here, I've got rebuild all succeeded. So you write a little bit of code and then you test it, right? So, because we're all human. I don't care how much experience a person has, you make errors. We're all human, every single one of us. That's why you write a little bit of code, then you test it. You write a little bit of code, then you test it. All right, is everybody good? All right, let's see what's next. So we are on step number 6. All right, we need to remove at method. In this method, we're going to copy all of the data down one single slot to overwrite the position that the user wants deleted. So this right here is very interesting how an array works. I'm going to go ahead and just kind of show you real quick. The array list is really good for a lot of things, but it's not the best solution for adding and removing items. Because if you add an item and you have hit the capacity, you then have to copy all of your items over to the new array, and that takes time. All right, so the other problem is if this right here, if we have 27, and then here we have, in this box right here, we have 13, and in this box right here, we have 18, and then in this box right here, we have 42, and then in this box right here, we have 71. All right, so if I tell you to delete the 13, okay, what do you have to do? If you come over here and then you just delete the 13 like this, then guess what? Anytime you reference that slot, your application crashes. Oh my gosh, that's insane. Does everybody get what I just said? Okay, you cannot leave a hole like this. All right, that's not allowed, because again, it will crash your application if you do. So what do? What you do is you actually have to copy this item to that box right there. Then once you do that copy, you then copy this item to that box right there. And then you copy this item to that box right there. And that's what you have to do. So and if you have 1,000 items, guess what? You have 1,000 copies. You have to literally copy all the way down just to remove an item, okay? And databases are built on arrays, and they're built on this type of technique. And if you've used Microsoft Access, you know that with Microsoft Access, you have what's called compact and repair. All right, how many of you have heard of compact and repair with Microsoft Access? All right, a couple of you? All right, so if you go to your Microsoft Access and look for compact and repair, that's actually what Microsoft Access does is it actually puts an X or some character like that into the slot, and it does not do the copy because it takes so long. It takes such a long amount of time. And then once you have a whole bunch of X's and your database is getting too big, it's taking up too much room because you have so many empty slots, then you hit the compact and repair, and then you go home and your database is down for an hour or two as it goes through and just compacts everything. And then it will do this. It will actually copy all the items down just like this to get rid of all the holes. All right. That's how much of a resource intensive action this is. So when you learn more about data structures, you're going to learn about something that's called a list. And the list, we can make stacks out of them. We can make queues out of them. And that's much, much faster for adding and removing data. All right. But for accessing data, the array list is the absolute fastest. So if you need to access data and you only add and remove every now and again, then the array list is the best way to go. All right. So this is what we're doing right here. If somebody says delete this, then we are literally going to copy every single item just like that on top of that item like that. All right. That's what we're literally going to be doing. Okay. So somebody tells us position 1, then we're going to start at position 1 and we're going to copy position 2 over position 1. And then we're going to copy position 3 over position 2. And then we're going to copy position 4 over position 3. That's the technique. All right. All right. So let's go ahead and create the method. And I'm going to pop over here and we're going to be doing a remove at. So here we're going to say remove data at the given position. So we're going to say int remove at, and then we're going to say int position, curly brace, enter key. Okay, this is going to take a little time to do. So, and I'm looking at the clock and we're already at a break point. In fact, I'm already into your break. So let's go ahead and take a little breather. When we get back from the break, we'll jump in and we'll take care of the remove at method. No problem at all. All right, so look at your watch, look at your cell phone, smartphone, and then add 10 minutes to that. I'll see you back in 10 minutes. If you're watching this as a recording, I'm going to pause the recording so the recording will continue on, no problem. All right, Catherine, we'll see you in 10 minutes, all right? All right, here we go. So, looks like I got rid of my picture too soon. The item that we want to get rid of is item at position. So they're telling us, here's the position, we want that one gone, right? So the item at that position we want gone. And we want to replace with the next one up. So we are going to replace it with list position plus 1. So we're going to replace the item at position with the item at position plus 1. And that's going to destroy the item at position, right? But here's the problem. We want the item at position plus 1 to be replaced with item at position plus 2, and then all the way up like that. So the way that we're going to do it is we're going to replace each item starting at the position with the item above it. And we're going to do that with the for loop. So we're going to say for, we're going to hit our tab key. And then we're not going to start at 0. All right, instead, we're going to start at position. So we're going to start at that item position that they told us they want gone. Okay? And then we're going to replace it with the item above it, all the way to the end. But we don't want our last item to be replaced with nothingness, right? We don't want to go outside of the bounds of our array. So you have to say -1. This is critical, otherwise you'll get an out of bounds, array out of bounds error. All right, so please be careful with that, because we're taking our last item and we're adding 1 to it. That's going to crash us. So you have to say -1. So we take the very last item and we move it to this position, and then that's it, we're done. Okay? All right, so now this line of code right here, go ahead and grab it and then drag it and drop it in here. And then here, instead of using position, we're going to use I. And then here we're going to say I. So the list at position I, which the very first one will be a position, but then we're going to increment by 1. That position is going to be wiped out by, it's going to be replaced with the item above it, the item 1 step next to it. See how that works? And that's how you do it, all the way up the chain. All right. Then we need to decrement. So we need to decrement the count. So we're going to say count minus minus, because we just got rid of an item. So this right here will do that technique that I showed you about copying all the way down like that. And then this right here says we just got rid of an item, so our count will be on. And that's it. All right, Catherine, do you have that? How are we doing in here? Is everybody good? Okay.
Oh, Professor?
Yes?
Yep, I've got it.
Awesome. All right, let's see what's next then. So here we want to get count and we want to get capacity. So those are going to be pretty straightforward, pretty easy. So we're going to pop over here and we're going to say return the count, and then we're going to return the capacity. So int get count, and we're simply going to return the attribute, that's all. And you notice that there's no setters for these, because we don't want these to be changed by the user. These have to be changed internally by the mechanisms. All right, so now this right here is gonna be int get capacity. And we're gonna return the capacity. That's it, we're on step number 7. All right, let's go ahead and pop on over here to our source.cpp. So this has our main method in it. All right, create a main method, we already did that. Check for memory leaks, everybody. This is really important. So, because anytime you create an application and you use the new keyword, you should instantly check for memory leaks. All right, so let's go ahead and do that. So I'm going to grab my memory leak code. I'm going to drag it and drop it in here. And if you have your memory leak code in your toolbox, you can drag it and drop it as well. If you don't, then type as fast as you can. And if you're here in class and you don't have the memory leak checking software code, please type it as fast as you can. And then go like this so that I know that you're typing, okay? All right, and if you are watching this as on the recording, of course, you can hit pause anytime you want, right? So, so make sure you type that in carefully. So in class, everybody good? All right, Catherine, do you have this code?
Hi, Professor. Yep, I'm good.
Perfect, okay, let's see. Create an array list that uses int data type, and we'll call it int list, and then add 6 numbers, and our default size is 5. So, and then we want to show the data, and then you want to show the count, and you want to show the capacity. All right, so let's go ahead and flip on over here, and then we're going to say array list, and remember with, oh man, my array list is not coming up. Nobody's saving my day. Why is my array list burning?
You have to include it.
Got to include it. All right, so up here at the very top, we have to do our include array list, like that. And remember, our stuff, we have to use quotes on it. So now if I do the array list, now it comes up. And then when you do a template, you have to use your brackets like this. And you notice I put one single bracket, and then down here it says, give me the type name. Does everybody see that right there? Give me the type name T. So here I want to work with int data type. So I'm going to put an int, and then this is going to be an int list, semicolon. So that's going to create the integer list. And then we're going to say int list dot add, because add is one of the methods that we put in there, right? And then we're going to say 17, and then int list dot add, and then we're going to put in 13, and we want to do a total of 6 of these. So I'm going to grab these 2, Control C, Control V, so that's 6. So here I will put 3, and then I will put 31. And then I'll put 42, and then I'll put 27. There we go. So there's my numbers. All right, so now we want to show the, so here we're going to test the array list with integers to see if it works. All right, so now I'm going to do a for loop, int, and then the size we know is 6 because we have 6 items. And actually, you don't even have to put in a 6. What I recommend that you do instead is just say int list dot count, int list dot get count. So that way, if we add more lines, just because we're having fun, then this right here will get the count based on how many items we actually have, which is perfect. All right, so now we want to do a cout, and then we want to say int list, and then we're going to say dot get. Remember that get method that we created? And then we're going to say get the item at position I, like that, end out. And then once the for loop is over, we're going to say cout, and then we're going to say size. And let's use a \n. So size, or actually, yeah, no, let's go ahead and say count, just so we're using the same words. Now I'm going to say int list dot get count, and then we're going to say cout, and then we're going to say capacity, int list dot get capacity, end out. All right, I'm gonna go ahead and run this and see how it works. And you can see there's a 17, 13, 3, 31, 42, and 27. And look at the count. The count is 6 because we have 6 items. But look at the capacity. The capacity started off at the default 5, remember? And then it got doubled. So the capacity is 10. So we actually have 4 empty slots in this array list. And you can see it's working perfectly. That's awesome. All right. Now I'm going to come over here to my output. I'm going to click on the output, and look at that. There's no memory leaks. So you definitely want to check your output, make sure you do not have any memory leaks. And that's because we use the destructor, and when we doubled the size, we deleted the old array using the delete keyword. So we took care of our memory very, very cleanly. We did a good job. All right. So please verify those couple things. And if you're getting a memory leak, or if your application is crashing, go look back at the code that we did and make sure that you don't have any typos or anything. All right. So how are we doing in here? Is anybody crashing? Everybody good? Nice. All right, Catherine, how are we doing?
Hello, I'm not sure yet. I'm still typing. I have blood right now.
Okay.
Oh, okay, hold on. I think I know what I did.
All right, I was about to stop sharing. I was going to tell you to flip your monitor over to me.
Oh, nope, I'm good. Thank you.
Good? Okay.
Yep.
All right. Then let's keep going then. So you're caught up on the typing too, right?
Not quite, actually.
Okay. Let me know.
I'm at the cout statement.
Okay. And then once you finish those last couple lines, make sure you run it and make sure it does not crash. If it does crash, please let me know. And then also check your output and make sure you do not have a memory leak. Remember,
right on.
Software development, you write a little bit of code, you test it. You write a little bit of code, you test it. In fact, for those of you who are really interested, Google test-driven development. Test-driven development. And you'll see how critical testing really is. When you're doing test-driven development, you actually do the test first, and then you write the code, which is kind of funny. So that really ensures that your application is very, very well tested. Then here we tested the array list with integers. Let's come on down here, and we are going to test the array list with strings. Because remember I said that it can work with any data type. Let's see if that's true. All right, add 4 names and then show the data types and the current capacity and let's see. right, so I'm not sure why we're supposed to only do 4 here, but I want to do 6. All right, so I'm going to go ahead and say array list, and the data type is string. Okay, so now we're going to say str list, and then I'm going to say str list dot add, and then jack. All right, and then we're going to grab this line right here, and we're going to do a control C, 2, 3, 4, 5, 6. All right, so Jack, Jill, Marcus, Alice, Bob, and Glenn. All right.
Maybe it was a double check to make sure it wasn't saving your account.
Okay, let's do that. So
Maybe that's why it didn't work.
let's go just 4, because Scott said that he thinks it might just be to test to make sure that it's not expanding the count, the capacity, I mean. So because this right here, remember, it was a capacity of 10. So if you only put in 4, will it maintain the capacity, the initial capacity? Let's find out. All right, so now I'm going to say cout. Actually, we want to do a for loop first. So I'm going to say int, and then we're going to say str list dot get count. And then in here, we're going to say cout, and then we're going to say str list dot get at position I, endo. And then we're going to say cout. And then we're going to say \n count str list dot get count. And then cout capacity str list dot get capacity. And then be careful with your parentheses also. These parentheses have to be there because get count and get capacity are methods, right? All right, now right here before the for loop, or actually let's do it up here. Right here, let's just do a blank line like that. So we're going to show the count, we're going to show the capacity and for our integers, and then we're going to put a blank line so it doesn't smash up against our strings, okay? And then right here, we're going to do the exact same thing. We're going to do a blank line like that. All right, so now if we hit run, and you can see we've got our strings and our count is 4, and look at the capacity. The capacity is 5, even though the capacity up here is 10, and that's because of what Scott said, we did not exceed the capacity. So there was no reason to expand the list. All right, and technically we should be able to add one more and it should still not change anything. So I'm just gonna add Bob. So we're gonna add 5 items to this, and it should not increase in size. Does everybody see that? So the capacity is 5. We have 5 items in there, so every single slot is taken, but that's okay. There's no reason to increase the size. But if we add one more item, then it will double the size of the array that's underneath the hood of this array list, as we saw up here. All right, how are we doing? Check your output, make sure that your output is still clean, and it should be. Catherine, how are you doing?
Okay, Professor. Almost there.
Okay.
I'm good, Professor.
All right. So now here is the wild part. Okay. We're going to test the array list with employee objects. So not primitives, but an employee object data type. All right. Now, in order to do this, though, we have to have an employee class. And instead of doing a full-blown employee class with a separate implementation and header, I'm just going to cheap out on this. And everybody, please follow me on this. Come up here to the very top. Look for using namespace. And we're going to actually create our employee class right up here. So we're going to create a quick employee class. So the class is going to be employee, curly brace enter key, and then we're going to have a private section, and then we're going to have a public section. In the private section, we're going to say string name. Actually, let's go string f name, and then string l name, and then string phone. And then double salary. And I can keep on going. I could create a full-blown employee class, no problem. All right, but I think this will make the point. All right, so here in my public section, I'm going to say employee, left paren, right paren, and then curly brace enter key, and then f name is going to be set to unknown. L name is going to be set to unknown. And then phone is going to be set to unknown. And then salary is going to be set to 0.0. All right, now we're going to create our parameterized constructor. So give me an F name, give me an L name, give me a phone, and give me a salary. And then this object's F name is going to be set to the F name that you gave me. And this object's L name is going to be set to the L name that you gave me. And this object's phone is going to be set to the phone that you gave me. And this object's salary is going to be set to the salary that you gave me. Notice I'm not doing any validation. All right, because like I said, I'm just doing a little quickie to demonstrate the concept. But if this were a production, it would be a full-blown header, full-blown implementation file with full validation, like we've been doing this entire session. All right, so you all know how to do it. But with this right here, I just want to just do a little quickie so that everybody understands where I'm coming from. Oh, okay. You too, Catherine. All right, let's do our toString. So I'm going to do a toString method. Just because I don't want to do getters and setters, so I'm going to do the toString method. So it's going to return fname concatenated with the value of fname, concatenated with comma spacebar lname, concatenated with the whatever's in the lname variable, concatenated with comma spacebar phone colon. I'm going to drop down to the next line, and now we can concatenate that with whatever's in the phone variable, and now we can concatenate that with the comma spacebar salary, and now I'm going to concatenate the string version. So I'm going to say to_string of the salary, like that. So remember, this string right here is an _s, lowercase s. All right. Through the session, I've had a lot of people misspell this, so please be careful with this. It's an _s. All right. So we didn't do any getters or setters because we're going to end up using the toString to show the data. But you all understand that I normally would have done getters and setters. I would have validated the input. I mean, the whole works. All right. So let's go ahead and scroll on down. And then right here it says test the array list with employee objects. So we're going to create an array list. But look at this, everybody. The data type, I'm going to say employee. Oh my gosh. Employee. So that's showing that I can literally work with any data type, literally any data type, okay? And then this is going to be an emp list, semicolon. So now I'm going to say employee list. We're going to add, and then we're going to create an employee object on the fly like this. So to create an employee object on the fly, and this is called an anonymous object. You just type the data type, and then you fulfill the constructor. So on this one right here, to fulfill the constructor, we're going to say, let's see, fname. Let's go ahead and say Jack. And then lname, let's go ahead and say Black. And then the phone number, let's say 555-1111. And then the salary, let's go 92,500.00. And there's our first employee. All right. Now I'm going to grab this line right here, this employee line. I'm going to do a Control-C, and now I'm going to do a Control-V, 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 and Control-V. So I'm going to create 6 employees to see if it resizes the array, and then just make stuff up. So I'm just going to go through and just make stuff up. Whatever comes to the top of my head, I'm just going to put in there. So Amy Walters. And then for the phone number, I'm just going to change it to 222 and then 333. Bless you. 444 555 666. And then let's go 97. Go 85. Let's go 102. And 93 and 84. All right, and then Bob Jackson, and then Maria Bettis, and then Mike Allen, and then Tom Donini. All right. Then down here, we want to see if it worked. So we're going to type a for list, and we're going to say int, and then we're going to say imp list dot get count, like that. That's going to tell me how many items I have. And then we're going to say cout, and then we're going to say imp list get the item at position I. Then once we have that item at position I, we're going to call its toString method. So everybody look at what I just did, all right? That's how you call the methods for the items inside of your array list. You get the item first, then you can use a dot operator to call its methods. All right, so now I'm going to go cout, \n count, imp list, dot get count, endo, and then we're going to say cout, and then we're going to say capacity, imp list, get capacity. So if I could do this with employee objects, I could have easily done this with car objects. I could have done it with guitar objects. Whatever you tell me, whatever data type you tell me, I could have created a class for that, and we could create objects off of it and drop them into our array list. No problem at all. That's how flexible it is when you learn templating. You can make your classes very, very flexible. All right, I'm gonna run it, just make sure I don't have any bugs. Oh, look at that, I got a bug. All right, would you like to continue? No, never. All right, return cannot convert from an int to an employee. Return. Return cannot convert from an int to a null PTR. Let's see if that does it for us. Cannot convert from a return cannot convert from null PTR to an employee. So this is an employee data type, and this right here, we could just do a default one like this. So that would be an empty one. So just T left paren, right paren. Let's see if that works for us. All right, so this works. This works, this works, that works. Beautiful, so there's our answer right there. So everyone, can you come over here to your array list, go to the get method, and here instead of returning null, go ahead and return T left paren, right paren. And that's just gonna be an empty object using the default constructor.
Can you go for the for loop below the inf list?
Right here?
Oh, I've got parentheses. Okay, I'm good.
Okay. All right, so I'm gonna run it one more time, just make sure I don't have any bugs. That looks beautiful. That's beautiful. And look at this. These are my objects. And the count is 6, the capacity is 10. That is beautiful as well. Nice.
Is this a kind of dumbed down version of how a solid state frame works? Solid state's all just arrays.
It basically is. Every single spot in memory, every single spot in RAM, whether it's RAM, a RAM chip, or whether it's a solid state device, each position is 0, 0, 0, 0, and then the one next to it is 0, 0, 0, 0, 1, like that. So when you drop data in there, you're dropping it into that spot, and then we reference it by using the location, the memory location. So you can kind of think of it as a huge, massive array.
Okay.
Because we're using
giant
the-
massive array broken up into a bunch of small arrays that keep breaking out, basically, right? Like rather than delete everything, you just delete a small portion to reformat it.
And reformat it, use it for something else.
Yeah.
Exactly. All right, so I want to say this again, because if you're watching the recording, you missed this. Your application may be crashing right now. And if it is crashing right now, go to your array list, go to the get method, and the return type here needs to be T left paren, right paren, like that. So we need to return an empty object versus null, because the employee was crashing on when we had null in there. So we need to return back an empty object. All right. And then when you do that, everything should run. To get rid of that ambiguous error for cout, all you have to do, Doug, is come up here to the top to your IO stream, put a // on it, then hit build, rebuild, and then come over here and then take the // back off, and then do a build, rebuild. And that should take care of your cout. That's a Visual Studio bug.
Okay.
All right, that is the lab. All right, let's go ahead and take a 10-minute break, and we'll get back from the break. We'll take a look at the My Programming Lab and take on at least one of those. I'll see everybody back in 10 minutes.